In this video, we're looking at net present value. And the way we want to think about net present value is think about you're making an investment and you're going to get cash flows back from that investment. And after a number of years, after you get cash flows for X amount of years, the net present value is the gain in value on your investment. So that's how we want to sort of think about this. So if you're going to pay $20 million in the secondary market for the winning Powerball lottery ticket, and you're going to get, and the prize or the cash flows back to you are going to be $2 million a year at the end of the year for the next 25 years. And the reason they're saying at the end of the year, because this is going to work like an annuity, not an annuity due. Anyway, and then the required rate of return is 8%. Now think about this as the cost of capital. So you've got to at least earn 8% because that's what you could have earned if you invested this $20 million somewhere else. So if we put that in right here, 8%, whoops, not there, here, 8%. And then we're going to put in our cash flows. Now, this first box right here, you need to put in the negative 20 million because that's what your 0, 0, 0, 0, 0, 0. That's what your initial cash outlay is. And then you're going to have cash flows of 2 million all the way down. So 2, 0, 0, 0, 0, 0, 0. So what I'm going to do is I'm just going to copy that. Go Control C, and then just go B. It's going to take a while, but we got to put 2 million in each one of these. Year 8, year 9, year 10. And now I'm just going to go like so and go Control C and go like so. Control V. Actually, if I wanted to, I could do it really quick by doing that, right? Okay. Now, that's it. There you go. So that it gives us our answer here and also up here. So our net present value is $1,349,552.38. Now, the takeaway here is it really depends on the discount rate. So if the discount rate goes down, that means your net present value is higher. Now think about that. That's because think of this as the cost of what you could get if you were to invest this 20 million somewhere else. So say you could get 10%. Well, if you get 10% somewhere else, then you're actually going to be negative. So you don't want to even do this, right? You would be much better off, investing your 20 million at 10% somewhere, right? Than to get these $2 million payments for 25 years. If the discount rate was 7%, your net present value would be much higher because these $2 million payments are much better than if you were to invest 7% somewhere else. And 8% is what we have. So there you go. So I'm going to go ahead and just do problem 5 at the same time. So let me, actually I can't because I've got to blank it out. But anyway, problem 5 is going to look at the actual internal rate of return for this same investment, and you'll see more clearly how this discount rate plays into the net present value. Okay, that's problem 10.4.